Okay.
You haven't seen that?
Nope. All right, so moving on. Okay, finally, question 13. I think this is where the recording stopped from my other one. So, okay, 13. We did an expression like this yesterday. Remember, order of operations PEMDAS. We're going to break this down into smaller parts. So, if you have a question like this, I want you to write the word PEMDAS, if you can remember.
Please excuse my dear.
No. So, what is the first thing I have to do to this question? Parentheses. What do we have?
7 minus 5.
Is
It is 2.
2. 7 minus 5 is 2. Okay, and then we're going to stop clinging around on whatever's going on there. And then we're going to bring down to the next level anything we haven't used yet. Okay, that means we've used those, bringing down everything else. Okay. What about time to move on to E for exponents? Do we have exponents this time?
Yes, you have 3.
Okay. Exponents, 3 to the second power, that's going to be 3 times 3.
Why did you write 3?
Oh, you're right. I wrote it. I was probably thinking 3, and I wrote 3. 3 to the second. Okay, so 3 to the second power means 3 times 3, right? 2 3s. It does not mean 3 times 2. Okay, so 3 times 3 gives me a 9. Bring down everything I haven't used. I used that. Seriously? Okay, remember with exponents, the little number tells us how many times we are going to multiply the base. So 5 to the third does not mean 5 times 3. It means we multiply the base 5 times. Okay? All right, so we did exponents. Let's move on to multiplication or division from left to right. What numbers do you see? What is it?
2 times 9.
Good, 2 times 9. 2 times 9, 18. Bring down the plus, bring down the 4.
Oh, that's a 4?
Yeah, 4, 4, 4, 4.
9.
Turn your music on. All right, finally, we don't have any more multiplication or division. We're just going to finish up. 4 plus 18 is 22.
I win.
Okay. So these problems can look really big and overwhelming. The goal, best thing is to follow PEMDAS and break it into small steps, and we're bringing it down all the time.
22.
22. Okay. Operations.
Ooh.
This is what Miss Blake likes to call a tricky question.
I don't think.
This is a tricky question. So the people who make the STAR test and questions like this, sometimes they throw in a few things that even if you know how to solve it, they're trying to trick you to get the wrong answer. Okay? So let's see if any of us fall for the trick.
I still have.
Hey, Julie and her 5 friends earned $432 at a bake sale. They agreed to split the profits evenly.
Oh, I know.
Okay, don't say anything. Okay, split the profits evenly. What operation would that be? Division. Among them. How much money did each friend earn? Okay, split the profits evenly. So we've got 432 divided by what?
6. Because you want to count herself.
That's the trick. About half of you all would look at the 5 and just write 5. But it's 6. It's Julie and her friends. That's her 5 friends. Okay. And if, as a math teacher, I don't like these kind of questions because it doesn't show me if you know how to answer it. It shows me whether or not you fall for the trick and then if you can answer it. how many times can 6 go into 43?
Zero. Wait, what?
7. Thank you. 7 times 6, 42. We're going to subtract. Get 1. Bring down the 2. How many times does 6 go into 12? 2. So each person is going to get $72. Okay. So when we take the test, I think we take it tomorrow in here.
What?
Yeah. Not in here. So the schedule for exams is 6th and 8th period tests are tomorrow.
Yeah, but it's advisory.
Yeah, so you're going to spend more time in advisory tomorrow. So tomorrow we are in here from 2:20 to 3:30 to test. These are almost exactly like the test questions. So when you see this question, really similar, I want you to think this is the tricky question. Okay, let's refocus. Anthony, why aren't you logged in? All right. I know you don't. Okay. Question number 15. Operations. Do not say an answer out loud. Okay. Which expression is equivalent to 3 divided by 1/5? I'm going to give you about 45 seconds to look at those answers. And maybe tell me something I can cross out, or maybe you'll figure out the answer. Which expression is equivalent to 3 divided by 1/5? Okay, who can tell me one thing I can cross out? Maddie. Yeah. It can't be 3 times 1/5. This is 3 divided by 1/5. That's like saying 3 divided by 4 is the same as 3 times 4. That's not the same. Okay? Somebody else? Tell me something I can cross out. Divine. What? D as in dog? Or B as in boy? Oh, I'm not touching that one yet. Somebody else, something I can cross off. What do you think? 1/3 times 1/5. Okay, the number 3 is not the same as 1/3. Okay, if I give you $3, that's not the same as a third of a dollar. That's 33 cents. Yes, same reasoning. Okay, let's look at D. 5/1 is the reciprocal of 1/5. So if I wanted to do keep, change, flip, this is what I would get. Right? Keep, change, flip. Okay. Keep, change, flip.
How is that the answer?
How is it the answer? Because we can't divide fractions. We have to change it to multiplication using KCF. Keep, change, flip. Kentucky Chicken Fried. All right. Quiet, please. Okay, so we're going back to the beginning of the school year when we started working on prime factorization.
What's that?
All right, so they gave us a number, 156, and we are going to break it down into just its factors, the prime factors. Anthony, stop rustling around with all that paper.
My fact is like,
Okay, so the list of prime factors is by my pink hedgehog right there. Okay, those are like from the first prime factors from 2 to 20 there. 2 to 19. Okay? Those are our prime numbers. So when we start this, we are going to divide. And since it's even, I'm going to start with 2. It's a good idea to always start with 2. So 156 divided by 2. How many times can 2 go into 15?
7, 6.
Yep, thank you. 2 times 7 is 14. We're going to subtract 1. Bring down the 6. How many times can 2 go into 16? 8. Yeah, 2 times 8 is 16. So 156 divided by 3 will give me, or divided by 2 gives me 78. Okay, still not down far enough. Still an even number. We're going to divide it by 2 again. 2, and I'm putting a circle around my prime numbers. So if it's not prime, it's not going to get a circle. So 78, half of 78. 78 divided by 2. How many times does 2 go into 7? Yeah. 2 times 3 is 6. We're going to subtract. How many times does 2 go into 18?
9.
9.
Yeah, 9. Ooh.
That's going to be a 0. Okay, so I'm out of even numbers. I'm on to 39. So I can tell by looking at that I can divide it by 3, right? Because a 3 and a 9, really? So we're going to divide this guy by 3. How many 3's go into 3? 1. How many 3's can go into 9? 3. 13, which is also a prime number. Okay. Okay, so we broke it down to all its prime factors. Now we're going to write it in expanded form, what we got left, what we ended up with. We had 2 times 2 times 3 times 13. If I plug that into the calculator and hit equals, I would get 156. But we're not done yet. Because this is an expanded form. It's not in the final factor form because look, we got 2 2's here. And when I have 2 2's like this, I'm going to change that to use an exponent. 2 to the second power. I have 1 3 and I have 1 13. It looks like a B, but it's a 13. 2 squared times 3 times 13, that looks like a B. Any questions on that? Huh?
Why is it so hard?
It's not.
It is.
Well, the good thing is that when we test, remember there's going to be more multiple choice questions. It's not all fill in the blank like this review is. Okay, so that's all on that page. Yay, fraction time! Let's put our fraction hats on.
No.
Think about fractions. All right. Whoa. It's going to act like that. If you're talking, stop. This is the one I want. Whoa. Okay, ordering fractions. I hear like talking video kind of stuff. Is that you?
Yes. Not him. It's back at this corner.
Oh.
Yeah, I wonder who it is.
Okay.
Probably her. Who?
Okay, Anthony, stay in your lane. Not your fight there. Okay, students voted for their favorite type of restaurant. The table shows the fraction voting for each restaurant type. Order the fractions from least to greatest. Okay, so there's more than one way to do this. We're going to start by making a number line. And I'm also going to make a fraction bar out of this rectangle where the word answer is. Okay, I'm going to pretend that that is one whole. So I'm going to cut it in half. Okay, and let's see, so this represents 1/2 right here. From 1/2, I'm going to cut it again into fourths, or divide it again into fourths. So 1/4 is 1/2 of a 1/2. Here's my 1/4. Okay, 1/4. Next, for 1/6, I can't make that on the same bar. Okay, so I'm going to go above it, and I'm going to make another fraction bar right here. And I need it to be in 6 pieces. So first I'm going to make it into thirds. And then I'm going to, well, that one's not quite big enough. Hold on. I'm going to cut it in thirds. And then each of those thirds gets divided again so that I have 6 parts. They're supposed to be equal, but they're not exactly equal. Okay, so 1/6 would be this much. Okay, there's 1/6. So far that's smaller than 1/4, right? And then finally, I have 1/12. So if I want to make 12ths, and I have it broken into 6s, I have to divide each of these one more time to make them into 12 pieces. And so here is my 1/12, this little guy on the end. Okay. So the biggest section I had was 1/2, right? So I'm going to put it on my number line here. 1/2 was the largest in this set. Next was 1/4. But let's pretend that I didn't do the fraction bar like this, and I just wanted to compare them. I'm going to compare 1/6 with 1/12. And we did this by doing butterfly and cross multiplication. So going from bottom to top, 6 times 1 is 6. And then this way, from bottom to top, 2 times 1 is 2. 2 is less than 6, which means this fraction is less than this fraction. Now, also, some of you, if you're good at fractions, and you can think in your head about stuff like this and how they all fit together, realize that as our numbers get larger, the size of our pieces gets smaller, right? So like 1/10 is a lot smaller than 1/4, as the denominator is bigger. And since all these have 1 for the numerator, it's really easy to compare, because I know the bigger the number, the smaller the piece. That's my smallest, because it's like cutting a pizza into 12 slices compared to cutting it into 4 slices. My slice sizes are going to be smaller with 12. Okay? And now this is from least to greatest. It's on my number line, so it's least to greatest. So you're going to see a question like that tomorrow. You can look at the fraction thing over here if you want. Woo. All right.
It's so plain.
Okay, back to integers. When Danny left Miami, Florida, it was 62 degrees. When he arrived in Fargo, North Dakota, the temperature was 5 below 0. What was the difference of temperatures between Miami and Fargo? All right, so more than one way to do this. I see the word difference here, so that tells me that I should use subtraction, right? So before I do that, I'm going to model this for you on a number line. My number line, I'm going to put a 0 here in the middle. This is where I'm going to put 62 over here. I'm going to put -5 right here. Now, I'm going to think about this distance change in temperature from positive 62 to -5 by using 0 as a place to stop. So from 62 to 0, That's 62 degrees right there. And then another 5 degrees. Well, this jump is 62. This jump is 5. So what was my distance to go from 62 to negative 5? Okay. I know that going from 62 to 0 is 62, and then I got to go 5 more steps below 0, right? So altogether, we've gone 67. Okay. Now, if I wanted to write that as a equation using subtraction, it would be 62 minus negative 5 equals. Okay. And when we have minus a negative, keep change flip, becomes plus a positive. 62 plus 5, 67. But then I got to think, is it positive or negative? Because the numbers are 67 spaces apart, but it depends on if I'm going from cold to warm or warm to cold. This guy went from the warm temperature down to negative 5. So in his case, the answer is negative. But if he was going in reverse and going back home from negative 5 up to 62 degrees, I would use 67 positive. Does that make sense? Was the temperature going up or was the temperature going down? Well, in this case, it was going down. Okay. I want you to jump to the last page real quick. We're going to jump to page 13, because we have not learned this yet, but it's pretty easy. Okay. X and Y, just like when we plot it, right, on the coordinate grid, first comes X, then comes Y. It's in alphabetical order. Same with when it's on a table. Okay. So this side of the table are my X values. This side of the table are my Y values. Now X is independent. I always think of him driving a little cartoon motorcycle. He has his little X here flying in the wind. He's an independent letter. But in his little motorcycle sidecar is sitting Y. Y goes wherever X tells it to. Y is dependent. So this D for dependent, Y goes with D, X goes with I. So you are dependent on your parents because you are still a child, right? You're dependent. They tell you what to do. Same with these guys. Okay? X is like the parent. He's the independent. He makes the choices. So down here, let's see which of these is true about these quantities. The value for H represents the independent quantities. Well, H is on the left, so I know that's my X side, and X is independent, so that's going to get a true. The second one, the values for P represent dependent quantities. P here is on the Y side. This is my dependent side, so this is also true. The values for H represent dependent. They're saying that this H is on the dependent side, and it's not, so that's false. So D, both A and B are correct. Okay. So in this example, the hours that you work determine how much money you make, right? So the hours are independent, and your payment depends on how much you work. Okay. Let's see, that's where we are going to pause this. And all right, so we ran out of time in class, so now I'm jumping back to question 19, where we left off before we jumped ahead. Which of the following expressions is equivalent to 5? So I want equal to 5. The rules with multiplying or dividing integers is if the numbers are the same sign, I'm going to get a positive answer. If they're different signs, I'm going to get a negative answer. And this is when you can draw a tic-tac-toe hashtag, and we can do positive diagonally like that through the middle, or diagonally like that for positives, and then all the rest of the numbers get filled in with negatives. And if I want to use something like this to help me remember, any way you go on this chart, you're going to get the right answer. If I go diagonally, a positive times a positive is a positive. If I go up from there, a positive times a negative is a negative. Okay, so down the middle, a negative times a positive is a negative. So any way you go on there, you're going to get the right sign. So let's check these out. The first one says negative 25 divided by negative 5. So I'm just going to treat it like 25 divided by 5, which is 5. And then I'm going to ask myself, are they the same signs or different signs? Well, these are the same, so my answer is going to be positive. So I know that that is a good answer. But there can be more than one correct answer on this question, so we're going to keep going. The second part, 1 times negative 5. 1 times 5 is 5. This time, I've got different signs, so it's negative 5. Different signs negative, so it's not number 2. For number 3, 30 divided by 6. Well, 6 times what number is 30? Well, that's going to be a positive 5. They're both positive. And our last one, 5 times negative 10. Well, 5 times 10 is 50, and they're different signs, so it's going to be negative. Okay, so it's not that one. But 1 and 3 were correct answers. We got positive 5, so that is down here on answer C. Oops. And all right, absolute value from the beginning of the school year, absolute value. Remember, absolute value is the distance from 0, distance. And absolute value is always positive. The distance from 0, and it's always positive. So which of these equations represents the absolute value of negative 9? So negative 9 is going to go through the absolute value bars, and it's going to turn it positive. Well, B and C both have negative answers, so it can't be those. And D here has this little extra negative, and that one means to take the opposite. The opposite of, take the opposite, P-P-O-S-I-T, take the opposite. So if I did this, well, let's read the question. Which equation represents the absolute value of negative 9? Well, negative 9 is going to go in there, and it's going to turn positive. This one says the opposite of the absolute value of positive 9, which is also 9. But if we take the opposite, that's going to flip over and be a negative 9. Okay? So that's not a good answer either. Okay, we've got 2 more questions to go. Inequalities. Inequalities. All right, Kimberly is, oops, let me get this straightened on my board here. Kimberly is selling popcorn for a fundraiser at school. Each student needs to sell a minimum of 20 buckets of popcorn. I'm also going to draw a rectangle around the word each. That's an important word. Kimberly has sold 8 buckets. So she's already sold 8 so far. Which inequality represents the number of buckets, B, that Kimberly still needs to sell? Okay, so I know that she sold 8. She needs to sell some more, which is going to be my B value. This is what she needs to sell. And let's look at that 20. Figure out which inequality needs to go with that. It says she has to sell a minimum of 20 buckets. So she has to get at least to 20. So that means she can do 20. She can do greater than 20, but she cannot do less than 20. Okay, so let's see which one of these inequalities makes the most sense. Well, A has a 12 for less than or equal to instead of 20. Number bucket, oh, she still needs to sell. Okay, so A can't be it. B, this is what she still needs to sell, plus 20 is greater than 8. That doesn't even make any sense. No, we have to have equal to or greater than 20, so it has to be one of these two. So down here, this is telling me I take the number that she already sold, and I'm going to multiply it by what she still needs to sell to get 20. That doesn't make sense. I wouldn't multiply to figure out part of a group to get to a total. But I would add it. So let's see this. This is what she needs to sell, plus what she already sold has to be greater than or equal to 20. Yes, that's the one that makes the most sense. More inequalities. All right. Joe charges $10 per hour for his lawn care. $10 per hour for his lawn care services. He currently is earning money to attend a concert. We don't need to know that. That's extra information. He needs to earn 150 or more. Oh, 150 or more. That tells me greater than or equal to. Okay, it can be 150 or more to attend the concert. Which solution best represents the number of hours Joe needs to work? All right, so I know that he has to make more or equal to 150. And I'm trying to figure out at $10 an hour how $10 and X. 10 times a number would be greater than or equal to 150. But they already did the math part for us. Okay, all these answers have their point on 15. But I need to look for something that's a closed circle because it has the equal sign with it. So closed circle, and it has to be going in the direction of my inequality, greater than. So A has an open circle, can't be that. B, the arrow is going this way, can't be that. D is also a closed circle at 15, the arrow going that way, they're the exact same. And C has the arrow going the right direction, and it is a closed circle. So that is our answer right there. All right. And that brings us back to here. And we've already done this one. We talked about how X is the independent, Y is called the dependent. Okay, and my value for Y is going to depend on X. We'll be working more with that in the next 6 weeks. So that's it for today. Testing starts tomorrow, and there is a new schedule, so pay attention for a message coming out about that. That's it.